So the Neolithic farmers of Western Eurasia are full of Neanderthal genetics, relatively speaking, compared to the Takarkori people who have a very small percentage of Neanderthal. So maybe we'll split up these two questions. We can maybe talk about how do we derive the age, and then let's talk about the mixture with Neanderthal genetics. So let's do age first. How do you determine the age of these divergences
So if
genetically?
so if we then separate again the mitochondrial DNA and the nuclear DNA, the mitochondrial DNA in some ways it's a bit easier because, as I mentioned before, the mitochondrial DNA is passed on from the mother to the offspring. So it allows you to build a phylogenetic tree, a tree of all the mothers, like a basically relationship tree of all the mothers. And we have a lot of those mitochondrial genomes from the past. So we have some from 10,000, 20,000, 30,000. The oldest ones we have are 45,000 years old, like the ones that Nada just mentioned from this woman from Czech Republic. And if we take all those mitochondrial genomes we have from people outside Africa, and they are radiocarbon dated because the skeleton is radiocarbon dated,
Okay.
we can basically build a tree, and we know every point in that tree, and that allows us to then calculate when the last common ancestor lives, because there's something called the molecular clock. So mutations happen through time. So we can then actually date how many mutations happen through time, how many changes happen to make a branch in a tree. And then you can actually infer the most recent common ancestor of two branches by just counting the number of mutations that were happening until a certain point. And then we can also calculate back in time when the branches are separated from each other. So you can basically use the fact that we have something from the past that is 20,000 years old, compare that to something else from the past or something from the present, and then we know how many mutations happen per year. It allows us to calibrate the molecular clock and then know when did something happen in the past by extrapolating from the observations that are happening on those branches. And then when we get the most recent common ancestor of all those mitochondrial genomes, for example, of 50,000 years, and the haplogroup, the type of mitochondrial DNA found in Takarkori, has separated from those others 50,000 years ago. So this is a way how we get that age when it separates, by basically having a lot of data points from a lot of those branches on the tree, and then inferring when one separated from the other, which works really nicely. So this is for mitochondrial DNA. For nuclear DNA, it's a bit more difficult. There we are often looking at the patterns that Nada just described about certain relationships to certain groups. And if we find that the Takarkori is part of the non-African branch, it is closer to people outside Africa than people in sub-Saharan Africa, we know it's on the branch of people outside Africa. At the same time, coming to your second question, it doesn't have Neanderthal DNA like all the people outside Africa. And we do know that the admixture with Neanderthals happened 47,000 years ago, but it doesn't share that. So therefore, the branch of Takarkori is older than 47,000 years. So it has separated some time between all people outside Africa, separating from the people in sub-Saharan Africa, and 47,000 years. So sometime between 60,000 years ago and 47,000 years ago. We don't know if it was 55, 52. The mitochondrial DNA tells us it's around 50, maybe 55,000 years. So somewhere in around that time. We can't date it much closer because there's too much uncertainty around it. But more than 50,000 years ago, likely, it has separated from non-Africans, where we have the nuclear and the mitochondrial genomes. And then again, it lacks the Neanderthal admixture that all people outside Africa show. But that's maybe also not a big surprise, because there were no Neanderthals in the Sahara. There were no Neanderthals in North Africa, how far we can say. There were no Neanderthals in Africa, period. So why should it have Neanderthal DNA if there were no Neanderthals there? But all people outside Africa have the same amount of Neanderthal DNA. All people outside Africa share an event where Neanderthals and humans coming out of Africa hybridized and carry this Neanderthal DNA. But they probably lived like on that lineage that that separated from the lineage that led to Europeans and Asians before they admixed with Neanderthals, sometime before 47,000 years ago. But that lineage stayed behind in Africa, whereas the other lineage that went into Europe and Asia, which became Europeans, Asians, Australian Aborigines, Native Americans, they had admixed with Neanderthals, probably somewhere in the Near East. That is the best guess that we currently have, because Neanderthals were living in what is today, for example, Israel. There were Neanderthals there when modern humans came out of Africa. And that's the most likely place in the Near East, somewhere where this admixture happened. But that's not shared with Takarkori, because they basically stayed behind.